Welcome to my channel. Today we shall be continue with our problems or past question under Dalton's law of partial pressure. So this is our example 3. So as usual, if you have not subscribed to this channel, you quickly do that as we keep updating you. Very important. So for those of you that have not gone through the previous classes on Dalton's law of partial pressure, you really miss, and I urge you to go back so that you can also follow what we're doing. So please study our classes on this Dalton's law of partial pressure for you to be able to understand or catch up with us. So very, very important. So if you have not subscribed yet, go to the subscription side or box and click on it as we move. Then you comment and like our videos. Very important. So can we go through this question? So look at it. Example 3 says that a gaseous mixture made from 5 grams of oxygen and 5 grams of methane is placed in a 0.01 dm³ vessel at 25 degrees Celsius. So question number 1 says that we should find the partial pressure of each gas. Find the partial pressure of each gas. Then number 2 is saying that we should look for the total pressure in the vessel. The total pressure in the vessel. So can we calculate? Let's calculate the partial pressure of each of these gas first. Then we'll go for the number 2 that say we should get or calculate the pressure in the vessel. So very, very important. So in our previous classes, as I said, we're able to establish relationship, that is derive formulas. So in that first class, you can see that we have about 6 formulas to solve questions under this. And today, because of that constant given to us, R, they say R is equals to 8.31. So because of that constant, we are also adding another formula. We are also adding another formula that is going to help us. So now, they said, let's bring out our data and calculate for the first gas, which is oxygen. So for oxygen gas, for O2. For oxygen gas, what is the molar mass of oxygen? The molar mass of oxygen is 16. Well, because it's a gas, so we are attaching this 16 by 2. So this by 2 is going to give us 32 gram per mole. 32 gram per mole. So that would be the molar mass of the gas. Then we should remember that the mass was given to be 5. The mass of O2 was equal to 5 grams. So what we are going to do here, you should know that since we are looking for the partial pressure, and you remember in one of the formula it says that for you to calculate the partial pressure of a gas, the partial pressure of that gas is equal to the amount or numbers of moles of that gas all over total amount or numbers of mole of all gases in that container multiplied by our total pressure. But now, as you can see that the total pressure was not given. So what was given in the question was a constant R, which is equal to 8.31. 8.31. So that's where the problem comes now. So it was 8.31 that was given. So let us see which formula can we use. So now if I get my amount now, from there I should know what to do. So you know that amount is equal to mass. Mass over molar mass. Amount, or what we call numbers of moles, is equal to mass over molar mass. So and our mass here, our mass is 32, right? Our mass is 32. So can we just go ahead and substitute this? This is 32. Sorry, our mass is 5. Our mass is 5. Our molar mass is 32. So if you divide 5 by 32, what do you have? So we have 5 divided by 32. So it gave us 0.165. 0.165 moles. Right? So that's good. So now you should know that the general volume, there was a general volume given. There was a general volume given. The volume is V is equals to, it gave us a volume in the question 0.01 dm³. and they say our temperature T is equal to what? 25 degrees Celsius. So you must convert this to Kelvin. If you are converting this to Kelvin, it will be plus 273, which is equal to 298 Kelvin. So they gave us our R. They say R is equal to what? 8.31. 8.391. So they are asking us that what is the partial pressure of oxygen? So we are calculating for oxygen first before we come back to what? Methane. So what is the partial pressure of what? Oxygen. So you know, if you look at this this formula very well, we can easily use this ideal gas equation that say PV is equal to what? NR what? T. Because if you look at this question or this parameter critically, our P was not given, our V is 0.01, our N is 0.165, our R is 8.31, and our T is 298. So this is the formula we are using. So if you make P the subject of the formula now, P is going to be what? P is going to be, if you make P the subject of the formula, so you have what? NR what? T over what? V. So your P now will be equal to, what is your N? Your N is 0.165 times R 0.831 times T, which is 298 over, what is our V? Our V is 0.01. 0.01. So if you multiply the whole of this now, the whole of this times 0.165 times sorry, this is 8.31 times 8.31, then times 298, then divide by 0.01. 0.01. So this is 38.69. So P here, P gave us what? It gave us 38.6 38.69 Newton per meter word square. 38.69 Newton per word per meter square. So this is our pressure, or this is the pressure we got for the oxygen gas. So we got 38.69 Newton per meter square. So that's very good. So can you see the partial pressure of oxygen? So can we go back to methane and calculate that of methane and see? So this is for oxygen. So then for methane now, for methane is CH4. CH4, right? So C is equals to what? 12. H is equals to 1. So and we have how many? 4 of the H. So that is we have 12. The molar mass is 12 plus what? 4, which is equals to what? 12 plus 4 is equals to what? Is equals to what? 16. So this is what? 16. So we said amount is equals to mass So amount is equal to what? Mass over molar mass. So we want to get the partial pressure of methane also. So methane, the formula is CH4. It's a hydrocarbon, CH4. So we say the molar mass of carbon is 12 and hydrogen is 1. So we have 4 of the hydrogen. That's 4. This is 12. That's what? 16. So the amount or numbers of moles of methane is going to be mass over molar mass. The mass is 5. The mass is 5. The molar mass is 16. So 5 divided by 16, what do we have? So we have what? 5 divided by what? 16. So 0.3125. This is what? Amount is equal to 0.3125 moles of CH3, like this. So that's good. So what is the partial pressure? What is the partial pressure of methane? You remember that the volume is constant, 0.01 dm3. Temperature is 298, the same thing. Then R is 8.31. So what is the partial pressure of what? Of methane. What is the partial pressure of methane? So that's what we're looking for now. What is the partial pressure of what? Of methane now. So now, still using this very formula here. Still using this very formula here. So if you use this very formula here, you say what? PV is equals to what? nRT, right? So therefore, P is equals to nRT over what? V. So that's what we're using. So then P will be equals to what? The N is 0.3125 times, what is our R? 8.31 times T. T is 298, right? All over 0.01. 0.01. So times this times 8.31 times 298 divided by 0.01. So we have 77. Our P here is equal to what? 77.38 Newton per meter what? Square. This is the partial pressure of what? Of oxygen. So this is the what? Partial pressure of oxygen. Sorry, of methane. Sorry, of methane. So now we can boldly say that the partial pressure of oxygen is equals to 38.969 Newton per meter square. Then the partial pressure of methane, is equals to 77.38 Newton watt per meter square. So this is what we have arrived at. That is, the partial pressure of oxygen is this, and the partial pressure of methane is this. Then they ask us that what is the total pressure? This is question 1, right? So now 2, what is the total pressure? And we should know that our P total is equals to what? Partial pressure of oxygen plus what? Partial pressure of methane, CH4. So then this will be equals to 38.69 plus 77 plus what? 38. So now our P total then will be equals to what? So now we have 38.69 plus 77.38. So it's going to give us 116.1 Newton per meter what? Per meter square. So that is the total pressure. That is what? The total pressure.